Now, in our next lecture, suppose here we are defining a unit vector. The unit vector is dimensionless and of magnitude 1. 1 means purely 1. That is, if suppose vector A in this sense, then vector A is directed in this sense, and this is a vector. This symbol is a specific notation of unit vector, which is in the same sense as that of vector A. Now, we define unit vector is a vector of unit magnitude and has no dimension. If A is a vector of any kind, then this symbol is a unit vector in the sense of vector A, and it is defined as this. Clearly, this vector is same sense of vector A because this quantity is, which is supposed to be 1 by modulus of A, treating as a lambda, which is always positive. But vector A is not a zero vector. Zero vector is a vector whose magnitude 0. So, for a zero vector, unit vector is not defined. Clearly, A is dimension, means unit vector A is dimensionless, because if A has velocity, means suppose 2 meter per second east, then this is also 2 meter per second. So 2 meter per second and 2 meter per second, only direction is east. This is equal to 1 and east, means there is no any units of this unit vector. If A has some units or not. Now, there are two types of unit vectors. One, a constant unit vector. Another is of variable unit vector. Here, variable unit vector is a vector of magnitude 1, same as a constant unit vector, and dimension is less. But variability arises due to it changing its direction. Now, suppose an example, a particle moving along a straight line, then there is two cases, one moving with a constant velocity or with a changing velocity. That is, here the constant vector means here constant vector V is constant vector, that is the magnitude as well as a direction are not changing with time. That is, if we say any vector is a constant vector, means there is no change in its magnitude, also in direction. Let here we show a figure. Suppose a particle moving along straight line. This is at t equal to t and this is at t equal to t dash. Here particle has a magnitude same as suppose over all instant of time along straight line. Then clearly speed is not changing, but if the direction of motion are also not changing, then the velocity means the vector v is actually a constant vector. That is, particle is moving along a straight line and in a same direction. This is actually meaning of constant of velocity. So in this case, the speed is not changing is called uniform motion. And in another case, suppose a particle is moving along a straight line but with changing magnitude of its velocity point to point. That is, the velocity vector is constant in direction but changing in its magnitude. So in this case, velocity is also changing due to changing its magnitude. Now question is there a changing in a unit vectors? Answer is no. Suppose if velocity is here 2 meters per second and directed in same sense as shown, suppose it is east, and here it is 4 meters per second. According to definition, the unit vector is v and the modulus of v. If v is not changing in direction, only changing in magnitude, if here is 2 meters per second, here also 2 meters, so 1 is 1, that is also is 1. And if it is 4 meters, here is also 4 meters, so it is always equal to 1 in magnitude. That is, if a velocity of a particle moving along a straight line is changing only in magnitude, so velocity is changing, but unit vector at any instant of point is not changing. That is, for this case, the time derivative of a velocity is 0. It says that velocity is constant with time. And if it is also 0, that is unit vector is constant. Clearly, this equation, differential equation, actually representing a moving particle which moving with constant velocity actually. This only equation represents the equation of motion of particle with constant velocity. But this equation is always valid for both cases if the direction of velocity is not changing. This is also representing the same situation, but it is also 0 when the velocity is not changing in magnitude also. Here is the case. Here particle moving in a straight line in same direction. Velocity is here v at t, here is t dash, v dash at t dash, and v double dash at t double dash. Velocity are changing in magnitude but not changing in direction. So velocity are changing as we suppose point to point, that is time to time. But unit vector at this point, this point, this point are not changing. That is, this is existing in both the cases. Here the differential equation, this is not zero because velocity is changing, but this will be zero because the unit vector at any instant of time for this situation is not changing, that is remain constant, so dc will be 0 with respect to time. Now if the particle is moving along a curve, the velocity obviously changing. It may be changing in magnitude or not, but on a curve the direction of velocity must change, so velocity must change. Here because the red mark is denoting a unit vector in the sense of v, here. So we observe that here the unit vector is also changing with time along this curve path. Now in next lecture we're discussing about the components of vector specific or rectangular component. Thank you.